Zeta potential is a key parameter for understanding the stability and behavior of nanoparticles in liquid environments. It helps predict whether particles remain dispersed in solution or begin to interact, aggregate, and eventually sediment. For researchers working with extracellular vesicles, viruses, lipid nanoparticles, liposomes, or technical nanomaterials, results depend on how reliably these particles stay dispersed, behave in solution, and maintain their integrity. In everyday research, nanoparticles are rarely homogeneous. Especially biological samples often contain mixtures of particles, background material, aggregates, or debris. So how can zeta potential be determined specifically for the particles of interest that matter most to your research, rather than as a single averaged value across the entire sample, as bulk measurement methods typically provide? To answer this, let's take a closer look at what zeta potential actually is. Zeta potential describes the electrical charge at a particle's surface. High absolute values indicate that particles repel each other and remain stable in suspension. As the charge weakens and the value moves towards zero, particles can begin to interact, aggregate, and eventually sediment. The surrounding medium has a strong influence on the measured value. pH, buffer composition, and ionic strength shape the electrical double layer around each particle. As ionic strength increases, this layer compresses, and the effective zeta potential decreases. Identical particles can therefore show different values depending on the medium, which makes reporting measurement conditions essential. To measure zeta potential accurately, the ZetaView Nanoparticle Tracking Analyzer uses single particle tracking. An electric field is applied to the sample, and the instrument detects how fast individual particles move. Their electrophoretic mobility reflects their zeta potential, while ZetaView automatically accounts for viscosity, temperature, and dielectric properties of the medium. Real-time visualization ensures full transparency during the measurement. Unlike conventional approaches, ZetaView does not limit you to a traditional single averaged value. Instead, it also provides a full zeta potential distribution across all detected particles, making shoulder and secondary peaks visible and suggesting heterogeneity or subpopulations that would otherwise remain hidden. With fluorescence mode, ZetaView introduces a globally unique capability for population-specific zeta potential measurements. This allows you to focus exclusively on your particles of interest, such as labeled extracellular vesicles, viruses, or lipid nanoparticles, while excluding background particles from the analysis. In addition to zeta potential, ZetaView measures particle size and concentration at the single particle level, providing a more complete picture of your sample. Particle Metrix supports researchers with installation, training, and application-specific expertise to ensure you get the most out of your instrument. If you want to truly understand the stability and behavior of your nanoparticle samples, explore what zeta potential measurement with ZetaView can reveal. Contact us today and schedule your demo.